Hello everybody. Let's discuss about arithmetic mean today, okay? And this video is meant for those who are taking a course like mathematical statistics, okay? That is a course you can usually take after taking up statistical methods and what you called and or elementary statistics, right? So the discussion will be more mathematical, and the examples, the questions we're going to discuss will also be more mathematical, because it is assumed that you've dealt with the more calculative problems in the previous courses like statistical methods and what you call that, elementary statistics. Okay, so now let's get started. First, we assume that n is positive integer, n is a positive integer, and we assume that x1, x2, xn are real numbers, preferably non-zero real numbers. Okay, and in elementary statistics and or statistical methods, these were usually positive real numbers. Okay, all right, then we define the mean of these numbers as x bar, denoted by x bar, and is defined by 1 over n times the sum of these values. Very simple. Okay, very simple. Now, this is the definition and this is the formula you've used to calculate the arithmetic mean of given values. Okay, we're not going to discuss that. Just assume that you've already done such kind of problems. So, and if you remember in the elementary statistics or statistical methods, that there was a formula for some formula called what do you call that? Step deviation method, assumed mean method, and it has many different names. So what that basically is, that if we take I to be any element of the set 1 to n and define di as all right, small case x, okay, xi minus a over h, where h is non-zero real number and a is any real number, but preferably we take both of them to be positive. Okay, if we define this di like this, then we can calculate the what you call that, the arithmetic mean of this data as a plus h over n summation I 1 to n di. This was what you have. This is a formula that you have used in previous statistics courses. Now let's derive it. Okay, the derivation is very simple. Let's begin with this. Okay, this thing. Then we can rewrite this as h times di is equal to xi minus a. All right, and this can be rearranged as xi is equal to a plus h di. Now let's sum them up. I was any element between 1 and n inclusive integer values, so summation I is equal to 1 to n, I runs from 1 to n, xi will be equal to, a is a constant so we can take it out, summation I equals to 1 to n times 1. okay, plus h is a constant, so we can take it out, and summation I equals to 1 to n, what is this, di. Okay, this is it. And next, let me keep it as it is. Xi, okay, is equal to a times summation 1 to n. 1 means n, so this is n times a, plus h summation I runs from 1 to n di. Okay, now dividing both sides by n, we're going to get the required formula. Okay, we're going to get the required formula. So dividing both sides by n, we get 1 over n summation I runs from 1 to n xi. Since we are dividing both sides by n, this n will get cancelled out, so we just have a here plus h over n summation I equals to 1 to n di. Okay, all right. So this, by definition, this is the arithmetic mean of the observation. So we can write x bar is equal to a plus h over n summation I equals to 1 to n di. Okay, this is how we get this formula for step deviation method. And here a is usually called assumed mean. A was usually called assumed mean. Okay, assumed mean. This is it. And let us discuss two properties very quickly, two very basic properties. Let me get rid of this. Okay, the first property is that arithmetic mean, let me just write x bar. Arithmetic mean is within the range of the given observations, Okay, observations. Now a very quick deduction from this definition, we can write n times x bar is equal to sum of given observations. Okay, so what do we mean by being within the given observations? This means if m is the minimum of these values, minimum of xi's, and m is the maximum of these values, then x bar is always less than or equal to m and is always greater than or equal to m. Okay, all right, let's see. X bar is equal to 1 over n summation I is equal to 1 to n xi. We can write it as 1 by n times x1 plus x2 plus xn, okay, like this. And by definition of a maximum value, m must be greater than x1, m must be greater than x2, like this, xn, all these observations, right? So we can say that it is less than or equal to each of these values are less than or equal to m each. Okay, m each. So there are a total of n m's. So this is equal to 1 by n times nm, which is equal to m. So we've just shown that x bar is less than or equal to m, right? Now similarly, since m is the minimum of these values, m is less than or equal to x1, m is less than or equal to x2, m is less than or equal to xn. Okay, so again this is 1 over n x1 plus, like this, okay, expanding this sum. This is equal to 1 over n greater or equal to 1 over m. Replacing each of these values by m, we need to, if we are to replace each of these values by m, then we need to replace equal sign by the greater than equal to sign, okay? Because this, okay, so this is m, there are n different m's, so this is equal to 1 by n times nm, which is equal to m. So we've just shown this whole. So x bar is within the range of given observations. All right, this holds. So this was one of the properties that we might have came across in elementary statistics. All right, now let's quickly discuss another, what do you call, property, the final one for this video. This is going to be a short video, okay, shorter video, not short video. My videos are not usually short. All right, okay, deviations about, first we need to define deviations about a given value. Okay, so let a be some real number, in applications preferably positive. Okay, I is any positive integer between 1 and n, inclusive. Okay, and let us define deviation di by xi minus a. Then di is defined to be the deviations about the point A. We define di to be deviation about A. Okay, and this is quite trivial. We define this as sum of deviations about A. Okay, sum of deviations about A. Oh man. Whoa. Are you okay, bro? Alright. And if A is actually equal to the mean of these observations, then di is said to be deviation about the mean. Okay, deviation about the mean, and this is said to be sum of deviations about the mean. All right, and the second property is sum of deviations about the mean is 0. Wow. All right, let di be the deviation about the mean. Then di is defined by xi minus x bar. Okay, now let's sum them up. Summation I equals to 1 to n di is equal to summation I equals to 1 to n xi minus x bar. We can rewrite this as summation I equals to 1 to n xi, and x bar is a constant, or at least it does not depend on I. We can take it out and we can write I equal to 1 to n, 1. Okay, so this is equal to summation I equal to 1 to n xi minus n x bar. Now let's see, from this relation which we have deduced from the definition of an arithmetic mean, we can write that summation I equal to 1 to n xi minus n x bar is equal to 0. So basically this is equal to 0, which shows that the sum of deviations about the arithmetic mean is 0. Okay, now this much for today. Thanks for watching. Take very good care of yourselves, and in the next video we're going to discuss 2 more properties. All right, discuss 2 more properties which will be related to sum of squares of deviations, and one is probably about combined mean, the so-called combined mean. Okay, all right, thank you very much.